Hello friends, how are you all? Okay, in previous video we studied about Newton's first law and which is directly connected with Newton's second law. And before we understand the second law, we need to explore our mind with some small thinking on that. Like first law, how was it derived? We took the help of inertia. In fact, first law is nothing but the law of inertia, which stated that unless unbalanced external force is applied to an object, the body or object will remain stationary or moving body will be keeping its motion. So that was the first law of motion, in which that state of stationary or state of motion was maintained by a body or an object. So inertia helped us to understand the first law of motion. Now friends, second law of Newton. Directly we learn this second law of motion, it is better to understand its track, that how does it move on. So momentum is the important quantity in physics which will help you understand this second law. Okay, let us discuss some practical examples which we encounter in our day-to-day life. First example, we know table tennis ball. Table tennis ball. Okay, if the table tennis ball is hit very hard and suppose it strikes with another player, does that table tennis ball injure that player? No, you will say, sir, it's very light in weight, it will not hurt at all. That's true, friends. Now second is the example of the cricket ball. If a six is actually hit by a batsman and some spectators try to catch it, or even the fielder, if he is there at the boundary, he tries to catch it. What happens? As soon as he that player or a spectator catches the ball, it hits them very hard. In fact, if spectators are not being attentive, it can actually fall anywhere on their body and it definitely injures that particular spectator. But what is the difference we are trying to bring out? This is table tennis ball and this is cricket ball. So you may be focusing at mass. You will definitely tell me, sir, mass of cricket ball is greater than the mass of tennis ball or table tennis ball. So that's why that cricket ball will surely hurt that spectator, not this table tennis ball. Okay, let us talk about some more example. Bullet. Okay, see, if I talk about the bullet, we know it can be terrible, it can kill any person, but it has to be fired from the gun. If it has to be fired from the gun, then only it is going to get so much of speed, so much of motion, so that it can penetrate the body of a person and can kill anyone. But at the same time, if I just take a bullet from the gun and just by my hand I am throwing it to anyone, what will happen? He will catch it. He or she will catch it and can run away easily. So the size of the bullet is so small. In that case, mass is not important, but you will say, sir, its motion plays a vital role. Motion, that we can call it, the velocity plays a vital role. Okay, friend? Okay. Now, we can also talk about some more examples, like truck. Okay. Now, when truck is actually parked on a roadside, when it is at rest, what happens? It will be unnoticeable. It is just standing somewhere parked on a roadside. It will be not noticed by anyone at all. But if a truck moving on a speed of 5 meter per second, okay, if it is moving, if it is in motion, and that truck can kill any person whosoever comes in its way. So it can be very deadly, it can kill. So here what is responsible? Truck standing or moving. Okay, in both the cases the mass of the truck is same, it's not changing at all. But here it is at rest, it's not going to get anyone, it cannot create any injury to any person. But here it's a moving truck, so it can kill anyone. So here again that motion is playing a vital role. So friends, what we are trying to understand, does this both means mass and motion, or velocity, do they have direct relation, or do they create any combined effect? Yes friends, this is nothing, this is actually giving you an indication to one more quantity, that is momentum, a very important quantity in physics which will help you to understand Newton's second law. But before we understand Newton's second law, you just try to make up your mind with this quantity, which is momentum. This momentum is denoted by P. So I'll write it this way: momentum is nothing but it's actually the product of mass and velocity. Mass and velocity, and notations or the symbols used to represent this quantity: small p, this is mass m, and this is velocity v. So this is how momentum can create an impact, okay, of force. Rather, let us try to understand. First, we will complete the derivation of its unit. So what will be the unit for momentum collectively, as the SI unit of mass is kilogram and SI unit of velocity is meter upon second. So it can be denoted this way: unit of momentum. Kilogram into meter into second is to minus 1. And since force is vector quantity and momentum is also be a vector quantity, since it will be in direction of the applied force, so this quantity momentum will also be called vector quantity. And friends, this quantity will help you a lot to understand Newton's second law, because before I switch it off, let me tell you Newton's second law. Newton's second law tells us that applied force F is directly proportional to the change of momentum upon time taken. One very good example with which we can understand it better, that time rate is also very important. Like before a bowler bowls the ball, he runs. Before a disc thrower throws a disc, he just move on a circular way, so that it can transfer that effect of the motion which is acquired by a person to a particular object, and for that time rate is required. So here we will see the effect of the force. It will work in order like it will be directly proportional to the change of momentum in a given time interval. So this is nothing but Newton's second law. Applied force is directly proportional to its change of momentum in time interval or in a time span. So friends, try to remember this momentum quantity, and Newton's second law will be very easy to understand. Thank you.